This lesson is about slopes and distance. The slope of a line is the ratio of its vertical rise to its horizontal run. You probably learned long ago that slope equals rise over run. When given 2 points, if you'd like to calculate the slope, the formula is slope equals y2 minus y1 divided by x2 minus x1. As a reminder, perpendicular lines are two lines that intersect at a right angle. Therefore, they form a 90-degree angle. Finding the slope when given 2 points, we use this formula, m equals y2 minus y1 over x2 minus x1, in which x2 cannot equal x1. If the x values are the same, we would get a 0 in the denominator. If a line is horizontal, which means that the x or the y values are come out to be 0, y2 minus y1 is 0, then we say that the slope is 0. If a line is vertical, in which case the x2 minus x1 is 0, then we say that the slope is undefined. If a line has a positive slope, we describe that slope as increasing. We often say the line is rising or it's going uphill. If the slope is a negative number, we describe that as a decreasing slope, and we often say that the line is falling, it goes downhill, something like that. In order to find the slope of a line through 2 points, there are a couple of steps. When you're given 2 points, you can identify a point as x1, y1, and another point as x2, y2. It does not matter which point is labeled as which. You plug the points into the formula. So for this example, y2 would be 2 minus 6, which is y1, divided by 4 minus a negative 1. When I simplify, I get negative 4 over 5. Because that's a negative number, we would say that the line is decreasing. In the second example, I have 2 different points. I allow my points to be negative 2, negative 3 as x1, y1, and negative 6, negative 5 as x2, y2. When I plug them in, I get negative 5 minus a negative 3. When you subtract a negative, you remember to add, so my numerator is negative 2. On the bottom, I'm going to have negative 6 minus a negative 2, which comes out to negative 4. And so when I simplify, negative over negative is a positive, and 2 divided by 4 is a half. Because this is a positive number, we say that this line is increasing. There are a couple of important postulates to know regarding parallel and perpendicular lines. The first is that if you have 2 non-vertical lines that have the same slope, if and only if they are parallel. So if you have 2 non-vertical lines, they happen to have the same slope, they have to be parallel. That's what it really tells us. If you have 2 non-vertical lines and they are perpendicular, it's if and only if the product of their slope is negative 1. And by product, remember, we mean multiply. So if you multiply the 2 slopes and you get negative 1, that is proof that the 2 lines are perpendicular. In example 3, we found the slope of the line parallel to the line passing through these 2 points. So in order to do that, I'm simply going to use the slope formula, m equals y2 minus y1 divided by x2 minus x1. I plug in my 2 points, and I find that slope is negative 4. Because I'm looking for the slope of a parallel line, it has the same slope. So the answer is negative 4. We can also ask, if I had a third line that passed through these 2 points, would it be would it be parallel to the lines above? In order to figure that out, I would use the same slope formula. When I simplify, I get a slope of a positive 1 over 4. Since the slopes are not the same, they are not parallel. In this case, it just so happens that they're actually perpendicular. Because if I were to multiply negative 4 times 1/4, I get negative 1. Therefore, the 2 lines would be perpendicular. In order to find the slope of a line perpendicular to another line that passes through two given points, as we're doing here in example 4, I'm going to use the slope formula, the 2 points that I'm given. I figure out that my slope is 7/3. Because I want the line that's perpendicular, I need to find the negative reciprocal. That means I'm going to start with 7/3. I flip the fraction to get the reciprocal 3/7, and I take the opposite sign. Since the original slope was positive, this one becomes negative, and I have a perpendicular line with a slope of -3/7. This next little section we're going to come back to in a later lesson, so I want you to flip over to page 7 in your course packet. This is where we'll have a discussion about parallel lines and distance. The distance between a point and a line is the length of the segment perpendicular to the line from the point. So in this drawing, if I have a line such as this, and I have a point, to find the shortest distance, I would draw a line between the point and the line, and I would take the segment as perpendicular. So for example, if I have another line over here and a random point, if I want to know the distance between the point and the line, I would drop down another segment or line perpendicular and find the measurement of that segment. Equidistant simply means that the distance between two lines is always the same. So if I have two lines, I would have to draw perpendicular lines between them and determine whether or not the measurement is the same. If it is, I can conclude that they are parallel. The distance between two parallel lines is the distance between one of the lines and any other point on the other line. It is always the shortest distance, and it's perpendicular. The distance formula we have touched on already, I do believe, and it says that distance equals the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared, and then I take the square root of the whole thing. So in the problem below, I have a line segment that's constructed from the point A, which has coordinates -4, 0, and it's perpendicular to the line R, and they intersect at a point E, which is 0, -2. So to find the distance between the point and the line, I'm going to use this point A and this point B, E. I plug them into my distance formula and simplify. In doing so, I find that D equals the square root of 20, which can be simplified to D equals approximately 4.47.
Oops!